So we are now in the fourth week in our pre-calculus subject, and our lesson for today is about ellipse. Okay, so I have here some illustrations of ellipse where we can find this in a real life situation. So an ellipse can be in an oval field, in also in the fruits that we ate, the watermelon, and also the symbols we are using for our business, our trademark, our any symbols that we use ellipse. Then also in the furnitures that we are using, we can also see the shapes of an ellipse. Okay, so let's have here the definition of an ellipse is the set of all points on the plane such that the sum of the distances from two fixed points is constant. The other parts of an ellipse are the following. So we have here the center of the ellipse is the midpoint of the major axis. Next, we have here the minor axis is a segment perpendicular to the major axis and its points known as the co-vertices. We have vertices or the endpoints of the major axis. So take note that vertices can only be found on the major axis, but our minor axis also has its co-vertices. Next, the major axis is the segment that passes through the foci and its endpoints lie on the ellipse. The focal distance is the distance from the center to a focus denoted as c, where c squared equals a squared minus b squared. So the focus, that is the point, plural form is foci, is the fixed point of the ellipse. Okay, so let's have here an illustration of an ellipse. Again, this is the center, which is the midpoint of our major axis. So when we say midpoint, that is can be found in at the center or the middle point of our major axis. And then we have here the minor axis, which is the vertical line. So how can we identify the major axis and the minor axis? The major axis, it has the greatest length, while your minor axis, so much lesser length than the major axis. Okay, so we have here the focus. So the plural for focus, that is foci. And then the distance c, that is the focal distance. So we use letter C to indicate that the distance from the center going to our focus, that is C. Okay, from the center going to focus is C. And for our major axis, we are using A. So from the center going to the vertex, that is A. Another from the center going to the vertex, that is A. So therefore, our major axis is 2A. Major axis. Oops. Next is our minor axis, which is from the center going to the co-vertices, that is B. And then from the center going to another co-vertices, co-vertex, that is B. So our minor axis is 2B. Minor axis. Okay. So I hope you understand where can we found A, B, and C now. Okay, so it says there that the length of these two segments, the sum of these two segments is just equal to the length of our major axis. So we have here the illustration. Okay, so suppose we have point F. We have here our foci, which is the F prime and the point F, and our center is C, and any point on the ellipse, which is xy. So when you add these two segments, the sum of these two segments is equal to the length of our major axis. So from here, going to the other vertex. That is the definition of an ellipse. Okay, so we have here the general forms of the equation of an ellipse, which is the ax squared plus cy squared plus dx plus ey plus f equals 0. So we have here the standard forms of the equation of an ellipse. If it is in the form quantity of x minus h squared all over a squared plus quantity of y minus k squared all over b squared equals 1, then the major axis is in horizontal form. So ang itsura sa graph is higda because it is in a horizontal form. Okay, let me draw it again. Oops, Pishwakan mouse, and I don't know how to control this. Okay, so that is the representation of our ellipse. Next, to solve for foci, that is h plus minus c, and then you copy k from our center. And then for the vertices, that is h plus minus a, and then you copy k. Co-vertices, that is h, k plus b, or plus minus b. And if it is in the form quantity of x minus h squared all over b squared plus y minus k squared all over a squared equals 1. So take note that a here is always our major axis and b is always our minor axis. So if quantity of y minus k over squared, if the denominator here is greater than, so therefore our ellipse is in the vertical form, which is nagapatindog ang ating ellipse. Okay, so to solve for the foci, we have h, and then to solve for the y coordinates, it is k plus c, k plus minus c, and then for the vertices, that is h then k plus minus a. For the co-vertices, that is h plus minus bk. Okay, so we have here an example. Graph the ellipse described by the equation a quantity x plus 1 squared all over 9 plus quantity of y minus 2 squared all over 25 equals 1. So we change this in the form of x plus 1 squared all over 3 squared plus the quantity of y minus 2 squared all over 5 squared equals 1. And then we identify A, B now, A, B, and C. So A here is 5 and B is 3. So since we know that A here is under our y quantity y minus 2 squared, therefore the equation or the representation of an ellipse or the major axis can be found vertical. So nagapatindog ang ating ellipse. Okay, so to solve for C, we have, oops. Okay, so to solve for C, we have C squared equals A squared minus B squared. And then solve for C, we have now square root of, you substitute A, that is 3, and you substitute B, that is, again, there's an error here. So our A here must be 5, and our B here must be 3. Okay, so let me change this part. Okay, so our C there is C equals square root of 5 squared minus 3 squared. So by simplifying, the answer is 4. Next, so for foci, that is k plus minus c. So our h there, our center is okay, so our center there is -1, +2. Okay, so you copy h, which is -1, and our k is 2. So 2 plus 4, which is our c, that is 6. And then you add, you subtract k, so 2. 2 minus 4, that is -2. So our foci are the points -1, 6, and -1, -2. Next is to solve for the vertices, which is h, copy the h, then k plus minus a. So for h, we have -1, you copy -1, and k is 2. So 2 plus a, which is 5, that is 7, and k minus a. So 2 minus 3, that is 2 minus 5, that is -3. So our vertices are the points -1, 7, and -1, -3. And for the endpoints of minor axis, that is h plus minus b, then you copy k. So our h is -1, -1 plus b, which is 3, -1 plus 3, that is +2. So we have here 0.22, and h, which is -1 plus -1 minus our b, which is 3. So -1 minus 3, that is -4, and then you copy k, which is 2. So the endpoints are the points 2, 2, and -4, 2. So you plot all the points that you get. So you plot -1, 2, and then you plot -1, 6. You plot the foci -1, 6. So you plot -1, 6, then you plot also -1 and -2. Points -1, -2. And next points are -7, -1, 7, then -1, 3. And then the covertices, which is points 2, 2, and -4, 2. And then you create the ellipse by connecting all the 4 vertices. So these are the co-vertices, and these are our vertex or vertices. And again, 4 here is the focal distance. So from our center going to the focus, the distance is 4. So so the distance from here is 4. Is next example, find the center and the foci of the ellipse whose equation is 16x squared plus 25y squared minus 128x plus minus 150y plus 381 equals 0. So we need to change this into its vertex form so that it is easy for us to graph the ellipse. Okay, so we change this into its vertex form by using completing the square method. So we have 16x squared minus 128x plus 25y squared minus 150y equals negative 381. Okay, then you do the completing the square. So I factor out 16 from x squared. So we have now, so you factor out 16 from 16x squared and 128x. So 128x divided by 16. So the answer is 8x. So 8x divided by 2, that is 4. So 4 squared, that is positive 16. Or negative 4 squared, that is positive 16. Plus, and then you factor out, oops, may squared pa din. You factor out 25 from 25y squared and 100, negative 150y. So we have y squared minus 150 divided by 25, that is 6y. So negative 6 divided by 2, that is negative 3, negative 3 squared, that is 9, equals negative 138, 381, negative 381 plus, so take note, nag-add ko di 16 sa left side of the equation, and may ara man kita 16 sa guwa sang parentheses, so that is 16 times 16 is 256. So, plus 256. Plus, so since nag-add ko di 9, times mo pa sa 25. So, 9 times 25, that is 225. Okay, you express this into its simplest form. So, we have x minus 4 squared plus 25 times the quantity of y minus 3 squared equals 100. Okay, so take note that your equation of an ellipse is in the form of x minus h squared all over a squared plus y minus k, oops, y minus k squared all over b squared equals 1. So how can we make the right side of the equation equals 1? So we divide each term by 100. So divide each term by 100 so that the right side of the equation will become 1. Okay, so 16 over 100, that is 4 over 25. And then you copy x minus 4 squared plus, so 25 divided by 100, that is 1/4. So we have y all over y times y minus 3 squared all over 4 equals 1. So going back to the equation of an ellipse, take note that we don't have a constant number outside the parentheses of x minus h squared. So how can we remove 4 here? So we can we can divide 4 to our equation of an ellipse, or by using the complex fractions. So this becomes 25 over 4 by its reciprocal of 4 over 25, that is 25 over 4, or I just divide 4 in this term. Squared plus y minus 3 squared over 4 equals 1. So we have now our equation of an ellipse in its vertex form. For now, it is easy for us to solve its center and the cosine. Okay, let's identify here the A, B, and C. So this can also be written as x minus 4 squared all over 5 halves squared plus y minus 3 squared all over 2 equals 1. Okay, so our A here is 5 halves, our major axis, or the length of our major axis, one of its length, that is 5 halves, and then our B here is 2, and for C, we need to solve for C, that is square root of A squared minus B squared, where A must be greater than B, because if B is greater than A, therefore, we will come up with a negative answer, and we cannot take the square root of a negative number because an imaginary number will be the result. So we have here now, let's substitute C equals square root of A squared, that is 25 over 4. So 25 over 4 minus 4. So the answer is 3 halves, or square root of 9 over 4, that is 3 halves. Okay, so our foci is, solve for the foci, that is h plus minus c, then k. Okay, so you substitute there. H is, okay, so our center first is, negative, positive 4, positive 3. So our H is 4, so 4 plus 3 halves, that is 11 halves. And then you copy K, which is 3. And the other point for the foci is H, so 4 minus 3 halves, that is 5 halves, 3. So these are the points of your foci. Okay, so if you have questions, can you message me in our group chat, and thank you for listening. God bless us all.